So we're starting with matrices today. So we're going to look at different types of matrices and what a matrix is. So a matrix obviously contains, it can contain numbers or it can contain letters, and it's a set of, it's like data put inside these rectangular borders or whatever, and obviously it's used like that and used a lot into computing and things like that. So matrices is things like that. So we put data in. Now we can see here with our matrix what we often refer to is we have rows. So if you look along here, this one has 3 rows, and then we'll also refer to the columns of it as well. So this one has 2 columns. So what we find later on that we need to know the order of a matrix. So an order of the matrix is always the rows by the columns. So you can see this one, it had 3 rows, and we just say by, so we use the times symbol, by 2 columns. So we always say, so rows is first. So rows before your bros. Okay, so rows and versus columns. Now, it's a very important, the order, particularly when we're going to look at multiplication of matrices with another matrix. So that's where we have to be careful. Now also, we have a way of identifying, so all these numbers or letters inside the matrix are called elements. So here we've got this matrix up here has 6 elements. So sometimes we want to talk about a particular element. So they refer to it by its row and column position. So here we're calling it A, and that's just because up here we called it matrix A. So if I wrote another matrix, I'm just going to make one up. Okay, and if I called that B, I could find element B. Now if I said B1, 1, you'll see 1, 1. That means I want to go to row 1. Sorry, I want to go to row 1, column 1. So I would say that's referring to 2. So down here, they gave you an example of the one up here, and they said A3, 2. So it means I'd go to row 3 and column 2, which was -4, and that's why they said -4. So what we're going to be careful is what they use to explain that is they call it A, and they say I and J. So they use these letters I and J. It was just to show you, and they'll say that I equals the row number, okay, and J equals the column number. Okay, so they'll write this statement out where they say I and J, but you just got to know that's what it means. I is row number, J is column number. All right, so if we said, and there's these exam questions that have this I and J, and this is the trickier part of this introduction to matrices, and there always seems to be questions in the exams. All right, so it says matrix A is a 2 by 2, and the element in row I and column J can be given by. So what they're doing is they want you to set up a matrix A. So I'm going to set up a matrix A, and what it's going to be is a 2 by 2. So what that means is you're going to have 2 rows with 2 columns. So it'll be 4 spots altogether. Okay, so I'm going to call, this would be row 1, row 2. This would be column 1, column 2. So what they're saying is I can make up this matrix using this rule. Now, remember that I equals the row number and J equals the column number. Okay, so what I'm going to do is I'm using this like formula or code that they've just made up to find what number goes in here. So I'm going to do this first example here. Now, because that is in row 1, that means I would equal a 1. Okay, and because it's in column 1, that means J equals a 1. So then if I use that rule to find what the element would be, it'd be 1 plus 1, which equals 2. So I did I plus j. So I know that one's 2. Now, if I do this one up here, this one's I equals 1, but j equals 2. So 1 plus 2 equals 3. So I know 3 goes in there. If I do this one down here, I equals 2, but j equals 1. So 2 plus 1 is 3. And the last one here, I is in row 2, so I is 2. J, it's in column 2, so j equals 2. So therefore, if I did 2 plus 2, it's 4, and that's why. So this was just an example. They've just given me this formula. They're going to give you formulas and with I and j involved in it, and you'll have to work it out. So this was just an example. So 2 subjects, I've got some VCE, some exam questions. 2 subjects, biology and chemistry, offered in the first year of university science courses. Matrix N lists the number of students enrolled in each subject. And matrix P is a list of proportion of these students expected to be awarded an A, B, C, D, E. Okay, write down, this is how easy our starting questions are. Write down the order of P. So we look for matrix P. What's the order of this one? How many rows has it got? 1. And how many columns has it got? 5. So it's a 1 by 5. Easy 1 marker. Now, it said explain what the matrix element P13 represents. So I have to go to row 1 and column 3. So what it means that so 0.175, like we could say, if we wanted to change that, because it says proportion, so we could change it to a percentage. So we could say 17.5% of the students got a C, yeah? You could leave it as a proportion and say that proportion of amount of students got a C. And they would have got that in bio and chem. That's the percentage they got. All right, so obviously entering into your calculator a matrix. So if you go and find this button on your calculator, it opens up this sort of timetable. So can everyone find that? And you can see that you have some options. So the options we're going to be using are along there. So you've got some quick keys. We often need a 2x2 a lot. So this is where you'll see where you've got that one. So if you click that, you get a 2x2 straight away, and you'll see it comes on your screen, and then you can enter your data in. So we also have a quick 1x2 as well, because that's often one we need a lot of, and also a 2x1. Okay, so they're quick keys, like quick ones. So quick matrices, so when we want to just get them up. Now, the last one, the one here that's highlighted, it actually looks like a 3x3. It's the one you can use to make whichever size matrix you want. So if you click on that, you then get asked how many rows, how many columns you want, and you just pick it and click OK. Now, over here, they're talking about, there's some instructions on how to store a matrix, because sometimes you may be using the matrix a lot. I preferably don't ever use this and don't like to use it, because once you start storing it as a letter, you then later on, you can't see what you're doing. So you can store it if you like to, because maybe in the chapter work. So to store it, you type in your matrix, so you can see they typed it in there, whatever it was. Then they got this arrow here. So that arrow is you go control and I think it's store. Okay, if you press control variable, but you'll see above it is in blue, so it's above the 9, you'll get that arrow, and then you can give it a letter, A, they gave it, and then every time you press A, it's going to produce that matrix. Okay. So what I was saying is I don't like to do this. What I want to do if you're going to use it again, say you have to type your matrix in and you need to use it a lot. So type it in and press enter and it just drops it over here again. So say that one they said here. So you've got it sitting on the right hand side. What I do is just always press your up key and just highlight it. And once the matrix you want, you've got the matrix you want, highlight it and press enter, it'll drop it down in your bar. Why I like that is because when you go back to check your work, you can see what you actually have, that matrix you actually used. If you've just got A and all that, then you can't see it written out and it can be confusing and you might want to just change it. It's up to you. I preferably don't do that. Okay, so we have different types of matrices and we need to know what they are because they often say, they'll give you some data and they'll say describe or display it in this way. So if you have a row matrix, obviously you can see there's always just one row. So the order, you'll always see a 1 in the front. If you have a column matrix, so you'll see just one column, so you'll see a 1 in the column as the second number in the order. Okay, very self-explanatory. A square matrix is obviously you've got the same amount of rows as columns. So you could have a square matrix can be like a 3 by 3 if you want. So that is also, sorry, I just made that one up. So that's a 3 by 3 is also a square matrix. Okay, the leading diagonal, a diagonal matrix is when you have numbers on the leading diagonal only and zeros everywhere else. So leading diagonal is when you start up in the top left-hand corner, you start and you end down in the bottom right-hand corner. So that is that's a diagonal matrix. So can you see only numbers there and the rest are 0? Yep. Okay. So we often may be talking about this leading diagonal. So just know that's when it's from the left down to the right. Okay, we also have triangular matrix. I've never really seen this much except for in a little multi-choice early on in this exam, like what type of matrix this is. So you've got your reference book. Obviously, an upper triangle means you have, see the numbers on the top triangle part and the bottom triangle has zeros. So that's an upper triangle, and a lower triangle is where the numbers are on down here on the bottom and the zeros are up the top in the diagonal. Yeah, I haven't really seen it used much in application except for just one off what is that matrix. Okay, the transpose of a matrix, they can ask you to do this and it's really easy. You are just switching the rows and the columns. So you can see here, I had this matrix up here. So this matrix was a 3 by 2. If you transpose it, it's going to be the opposite, a 2 by 3. So you can see that, say this row became a column, yeah? And that row became a column and the last one become things. So if you just have to write it out, it's pretty simple. So they will often refer to transpose. They'll use this little T up here, okay? So that just means transpose. And obviously the order's just switched around. Really easy. Just a thing that's forgotten about once you get to the end of the unit. People forget about it and then it gets a little question snuck in here and there. Okay, so determining the transpose on your calculator, so you can do it. So it says enter the matrix into your calculator, so you go and press that button. They're going to do this A1 first. Move the cursor to the right so it's outside the matrix. Press menu 7-2. That would get you to menu, matrix, vector, and transpose. Really, it's not hard to manually transpose it. Just transpose it yourself. But in case you're checking, you want to be sure, you can do that. All right. So there's a little example. I've never done it on the calculator, so there you go. All right, so a symmetric matrix is a square matrix that is unchanged by transposition. So if you transpose a square matrix and it looks exactly the same, it is therefore a symmetric one. So let's have a look. I'll just call this this matrix A. So if I go A transposed, watch me, I'm going to change, I'm going to make this row a column. So that means it would be 2 and 3. And then I'll do this row a column, be 3 and 1. Can you see, do I end up with the same? Yeah, and that's why these ones, it's a symmetric, because when I transposed it, I got the exact same thing. All right. The next one is an identity matrix. This one's really, we use a lot. It becomes really important. And it has ones down the leading diagonal and zeros everywhere else. Now, what will help you if you consider the identity matrix as a number 1. So matrix like a number 1. So what do I mean by that? If I had, say, matrix A and I multiplied it by an identity matrix, what I end up with is matrix A. So isn't that the same? If I go 3 and I times it by 1, don't I get 3 itself again? So an identity matrix is sort of like a number 1 in matrices, yeah? So that can just help you with problem solving, or because sometimes if you're using it and you go, well, won't this change the value of it? Well, no, it won't. Okay, a null matrix just has all zeros, pretty easy, and 2 matrices are equal if they are in the same order and the elements. So you can only say they're equal if they're exactly the same, but that's pretty self-explanatory. All right, you're going to start 11A in a minute. So the order of the matrix X is a 3 by 2, and the element in row I and column J of matrix X is Xij. So you're going to see this written, this little statement written all the time in your questions. And that's what I said. What it's telling you is I is representing the row number and J is representing the column number. They just have to state it. Okay? Now, they're saying that the rule to create this matrix, we're going to use this. Okay, so first of all, we know it's a 3 by 2. So which ones can we get rid of? C. Yeah, we can get rid of C. It's not a 3 by 2, so we'll get rid of that. So what I'm going to do, I'm going to do it myself. We said, I'm going to create this matrix a 3 by 2. So I'll put a little spot in each, and I'm going to draw it up myself so I can just get the answer. So this would be I equals 1, I equals 2, I equals 3. If you're in that row, that's what it is. If you're up here, J will equal 1 and J will equal 2 along going down that way. Okay? So if I look here, this one here, they're saying add them again. So it'd be 1, I is 1 and J is 1, so 1 plus 1 is 2. If I do this one, I is 1 and J is 2, so it equals 3. And what about the rest? So we've got 2 plus 1 is 3, 2 plus 2 is 4, yeah? 3 plus 1 is 4, and 3 plus 2 is 5. So I'm looking for that one where it says 2, 3, 4, 5, and that was E. Boys, let's do this one really quickly. Transpose this. So we're going to have the rows become a column. So as I said, it's pretty quick to do it yourself. So where's our answer for that one? Is D. So I wouldn't do that on the calculator. Okay, consider matrix P, where it's here, where the row I and column J of the matrix. So I told you they're just going to always say this. They have to say it, okay? All right. So it says the elements in matrix P can be determined by. So what I have to do is I have to test each of these rules and see if it produces this matrix. So if you have a look, if I'm going to do this option, this first option. So what it's saying is, if I was, and I'll just draw a blank one over here. So this is option A. So I've got the 6 spots. Okay, so what this would be I equals 1, I equals 2, J equals 1, J equals 2, J equals 3. Okay, what they're saying for me to do the rule, they're saying the rule is 4 minus J. So up here, J is 1, so 4 minus 1 would be 3. What about in this spot here? It'd be 4 minus J, which is 2, so what would that be? Is 2, and the last one would be 4 minus 3, so that's 1, that worked. Now let's try the next row. This one, because the rule says 4 minus J, so it'd be 4 minus 1 equals, which equals 3. Now already that doesn't work, does it? That's not what's there, so that one's out. Okay, so now I'm going to try the next rule. So here, so I'm just going to draw it in green. Okay, so the rule is saying to do 2i plus 1. Okay, so in this spot here, I is 1. So 2 times 1 is 2 plus 1 is 3. So that works. That gives me that. And what about in the next one? It would be 2 times 1, which is 2 plus 1. So this is not going to work, is it? It's going to be 3 along the whole top. So that one's out. We'll get rid of that one. He's not the answer. Let's try the next one. This one, okay, I'll just draw it here. Okay, so in this spot, I'm going to do the first spot. It's going to be the I plus J. So this one's I equals 1, J equals 1. So it'd be 1 plus 1 plus 1, which is 3. In the next spot, J equals 2. So it'd be 1 plus 2, which is 3, plus another 1, which would be 4. Is that what's up there? Nah. So we'll get rid of that one. It's not that answer. Okay, I'll try D now. It's going to be the last one, isn't it? It's going to be annoying, but anyway. All right, let's try D. Okay, so D's saying we've got I equals 1, I equals 2, and J equals 1, J equals 2, J equals 3. Okay, in the first spot it says I plus 2J. So I is 1, J is 1, so it'd be 1 plus 2. That gives me 3. Here in the next one, it'd be 1 plus 2 times 2, which is 4. So what would that would be 5. It's already not the answer up there, so that one's out. And looky what we got, last one. I'm tipping this is hopefully the answer. And we've got the first one, so 2 times I, which is 1. So, sorry, I equals 1, so it'd be 2 times 1 is 2, minus 1 for J, which is, what did I say? 2 minus 1, so I'm back to 1 plus 2 is 3. This one's getting confusing. I'm going to try this one down here. So I equals 2 and J equals 1. So the rule says 2 times I, which is minus 1 plus 2. So that'd be 4 minus 1 is 3 plus 2 is 5. So if you keep going, you're going to get all of them. I'm not going to go through them, but we are looking like we got the answer and all the rest were wrong. So I would just take that answer and I'll move on because I've already spent too much time on it. And when I come back, I will check when I'm checking my work, I'm going to check that those other 4 elements proved right as well. Okay? Because that way I'm checking something I didn't do. Going to say we got C. So when we work this one out, we got C to be good. So I moved on, and when I come back, I'm going to check that these ones disprove. Yes. So when I come back to I check those ones that they don't work either, and that way I know I'm correct, and I've checked my work in a different way. All right. The table below shows the information about 2 matrices, A and B. The element in row I and, yep, so they're just saying that rule again, and they've had to say it twice because they've got two matrices. So they're saying the sum of A plus B. So what you have to do is you have to create matrix A using this rule. So matrix A is a 3 by 3. So up here I'm just going to do that. So we've got I equals 1, I equals 2, I equals 3 in this spot, and this would be J equals 1, J equals 2, J equals 3. Okay, the rule says to go 2 times I plus J. So 2 times I is 1, so 2 times 1 is 2, plus 1 is 3. So this one would be 2 times 1 is 2, plus 2 is 4, and then 2 times 1 is 2, plus 3 is 5. Okay, and then you've got to do the next row. So 2 times 2 is 4, plus 1 is 5, and 2 times 4 plus 2 is 6, and 4 plus 3 is 7. And then I've got to do the last one. So 3 times 2 is 6, then plus 1 is 7. So 6 plus 2 is 8, and 6 plus 3 is 9. So that's A. Got matrix A going. And then I've got to do B. And B's got a different rule. So B is I minus J. So 1 minus 1 is 0. And then I've got 1 minus 2 is negative 1. And then 1 minus 3 is negative 2. Okay, the next row, I is 2. So 2 minus 1 is 1. 2 minus 2 is 0. And 2 minus 3 is negative 1. Then the last row, 3 minus 1 is 2. 3 minus 2 is 1, and 3 minus 3 is 0. Okay, then the question wants me to add them, which we're going to learn pretty quickly, which you've already done. When you add matrices, you just add the same spots. So 3 gets added to 0, so I should have a 3. So look at this, I'll get rid of those ones. And then 4 gets added to negative 1, so that would be another 3. And there's only one with that answer there, isn't there? So bang, D.